Hello friends, good morning.
Good morning, sir.
Very good morning, sir.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Yes, good morning. How's the preparation going on? Good? Yes, okay, right. Now we'll start the session. So the next few sessions on math, stats and logical reasonings, the objective of this revision class is those who are comfortable with this subject, try maximize your marks here so that it helps you to get the total aggregate. Those who are still not too comfortable with it, we can still get 60 in this. Okay, that is the objective. That's the objective of this particular session. We have to get 60. It's easy. We can easily score. We'll see which are the areas that we have to focus on so that we can optimize our marks. And I think I would have spoken about this in the regular classes as well. So how should our focus be is we should score maximum marks in logical reasoning, right? Preferably 16 to 18 marks. Statistics, we can easily score 30 out of 40. And mathematics, even if we score 15, we'll still get 60. Okay, 15 out of 40. And I'm going with this purely from scoring from the examination point of view. So how will our session go? First, we'll start with our topic that we are comfortable with, statistics. Right, we quickly go through all the provisions of all the concepts of statistics. Anyhow, we had discussed this in detail, right, in the class. So we'll quickly look into this and we'll also solve some problems. Okay, so that we are comfortable with this, and then we can move on to the other topics, logical reasoning and mathematics. Is that clear?
Yes.
Yes. Okay. So with this, we'll start with the first chapter in statistics. That is statistical description of data. It's the basic introduction, right? So here we have the definition. First, to start with origin. The origin of the word statistics, Latin word status, Italian word statista, German word statistic, French word statistic can be asked in the exam, right? So very, very important. They can ask us to find out the odd one out. They can just give us these four. Or instead of statista, they can give any other word and ask us to find out the odd one out. Or they can ask us any of this, like what is the German origin of the word statistics. So how to remember? Now, Latin and Italian, we have to remember. Latin status, Italian is statista. German, okay, it is not C, it is K, statistic. German word, it is statistic ending with K. And French, QUE, ending with QUE. That's the difference. So this is how we have to use some techniques to remember. Now, coming to the definition, there are two definitions. One as a statistics as a plural noun, and one is statistics as a singular noun. As a singular noun, the entire process involved in collecting the data, right? Process involved in collecting, classification, analyzing the data. Basically, whatever chapters that we have in the syllabus and put together, singular noun, it is called statistics. Whereas the data that we have collected itself is called statistics in plural sense. Data that we have collected itself is statistics in plural sense. In singular sense, the process that is involved, right? What? Yes, we have also discussed that statistics is widely applied, right? It has lots of applications, lots of advantages. However, there are certain limitations as well. Very important 4 limitations. It deals with aggregates. So if we have one single information, we cannot do any statistical analysis. We should minimum have a couple of informations, right? So it deals with aggregates and it's concerned with quantitative data. So does it is that the case that it doesn't take qualitative data altogether?
Sir, if qualitative data is expressed in numerical terms, it takes, or else it won't.
So for analysis of qualitative data, we have to express the qualitative data in numerical terms. Correct? So it's concerned with the quantitative data, and future projections that we make are satisfied, holds good. Basically, future projections holds good only under a specific condition. So that regression, best example is regression chapter. In regression, we have the regression lines of y on x and regression line of x on y. What are these? These are the relationship between y and x and y, depending on which is the independent variable, which is the dependent variable. Now, based on this, if I'm taking y on x, value of x, can I project or can I estimate the value of y? Yes, we can do that. But that estimation will hold good only if this relationship is satisfied. Correct? Only under that specific condition, the future projections are valid. That is the third limitation. And fourth one, theory of statistical inferences is built on random sampling. So if that concept of random sampling itself is not followed, whatever conclusions that we're making might be wrong. Right? These are the four limitations that we had in statistics. Then we discussed about data. Now, data, whatever information that we collect, right? It's called data. There are two types: qualitative data and quantitative data. Qualitative data is called
Attributes.
attributes. Correct. Qualitative data is called attributes. Quantitative data is called
Numerical facts.
variable. Right? It is called variable. Under variable, we have two kinds: discrete variable and continuous variable. What are discrete variable? Those variable which takes only finite number of values in the given range. They are discrete. However, if they take any number of values in the given range, they are continuous. Simple, easy to remember. If that particular variable cannot be expressed in decimals, then they are discrete. For example, number of accidents, number of petals in a flower. We cannot have 0.5 accidents. We cannot have 3.5 accidents, right? It is either 3 or 4. So it cannot be expressed in decimals. Therefore, they are discrete variables. If it can be expressed in decimals, then it shall be continuous variable. That is how we should remember. Apart from that, we also had another classification. One, primary data. The other one was secondary data. What was primary data?
So when we collected first hand.
Yes, data collected for the first time, right? Fresh data. That is called primary data. However, if we use the data already collected,
It is already collected.
Already the
already collected data, then that is secondary data.
data.
Yes. Now, that's the second category, primary data and secondary data. Now, with regard to collection of primary data, we have four methods. First one, interview method. So in interview method, as the name itself says, we ask questions and get the information. But there are three methods under that, three ways of conducting the interview. One, personal interview. Here, what the interviewer will do, he will personally visit the area, visit that place and get the information, right? From the persons who are affected, who are the subject in charge of that particular issue. So, for example, in case of natural calamities, those who are affected by natural calamities, from them, if we collect the information, that is personal interview. Second one, indirect interview. In case of indirect interview, we're not in a position to collect the information directly from the person who is involved, who is a victim of that particular issue. Hence, we go with the persons who are related to that, who are associated with that issue. Right? In case of accidents, if there is loss of lives, then we go with the eyewitnesses of that accident, right? So that is indirect interview. And the last one, telephonic interview. So here, as the name says, we collect the information over phone, right? Over the phone. Now, what are the advantages here individually? In case of personal and indirect interview, the data collected is accurate.
Accurate.
Right? They're accurate and consistent. However, the disadvantage is
Time consuming.
Can be manipulated.
time consuming. Very good. Time consuming. And we cannot cover large areas. Large areas cannot be covered. Cost is involved. Correct? Whereas in case of telephonic interview, we can cover large areas. That's the advantage.
Less number of responses.
We can reach more.
Less cost is involved. Correct? Less cost is involved.
Less time.
However, less cost and time. Correct. However, accuracy is an issue, and more importantly,
Non-response.
Non-reliable.
non-responses. Accuracy, yeah, accuracy and consistency. Since it's less consistent, it's not reliable. But most important disadvantage is non-responses is maximum in case of telephonic interview. Understood?
Yes, sir.
Yes, sir.
Yes. Yes.
Okay.
That is about the interview method. We have 3 types: personal interview, indirect interview, and telephonic interview. Advantages of interview method as such, though it is less consistent, has a wide coverage, number of maximum responses. In this case, basically telephonic interview, advantages and disadvantage. Next one, mailed questionnaire method, second one. Now, in case of mailed questionnaire method, we prepare a questionnaire of all the information required. We convert them into questions and we would send it through mail. It could be electronic mail or physical mail, right? We send it through mail. The respondents have to fill in the information and send it back. However, compulsorily, along with the questionnaire, there should be instructions or guidelines for filling that
Cover
particular
letter.
questionnaire. Yes. Now, what are the advantages here?
In short time, we can cover
We can
large.
cover large area here. Yeah, within limited resources, we can cover large area. However, disadvantage
Non-responses.
Non-responses.
Non-responses are high.
very high. Yes, non-responses are extremely high in case of mailed questionnaire method. Right? Although a wide area can be covered using mailed questionnaire method, number of non-responses is likely to be maximum in this method. Third one, observation method. Now, under observation method, we are not bothered about asking any question to that particular person. Instead, we would observe the activity conducted and get the information. We shall observe and get the information. Example, we have discussed an example, right? Medical examination in our schools, right? So there we had weighing scale, we had height related scale, and we had to just stand besides that and they would observe and get the information, the heights and weights of the students. So that is observation. However, they can use instruments, equipments required for collecting the information. What is the advantage here?
So it is accurate.
Accurate.
Accuracy.
Yes, the most accurate information that we get here. Why? We are not relying upon the answers given by that person. We are relying upon ourselves to get the information, right? So it's the most accurate. However, disadvantage,
It needs
Time
equipment.
Time
and it's
consuming.
yes, time consuming, and we cannot cover the large areas. Only small areas can be covered. Yes, although this is likely to be the best method of data collection, it is time consuming, laborious, and covers only a small area. That is observation method. And last one, questionnaires sent by enumerators. So best example of this is sensors. So here, yes, we prepare the questionnaire, but unlike mailed questionnaire method, we shall not send it through mail, nor the person who want the information go and collect. Instead, what they do, they appoint agents, enumerators, to collect the information. So these enumerators will be trained, will be instructed on how to collect the information. They will be allotted certain number of certain areas, and they shall go and get the information from that area by individually meeting the respondents, right? So that is questionnaires sent by enumerators for use for larger inquiries from the persons who are surveyed. Enumerators collect the information directly by interviewing the persons having information. Questions are explained and hence data is collected. That is about how do we collect, the different methods of collecting primary data. Clear?
Yes, sir.
Yes. Next, we have sources of secondary data. It can, so secondary data sources can range from international sources to local unpublished sources as well, right? Any sources, international sources like WHO, ILO, IMF, World Bank, government sources like the government department, statistical abstract by Central Statistical Organization, or Indian Agricultural Statistics by Ministry of Food and Agriculture. Then we can have private and semi-government agencies like ISI, ICR, NCERT, unpublished sources of various institutes, IITs, IIMs, etc. Unpublished data can also be relied upon. So it can be any sources for the purpose of secondary data. Once we have collected the data, we cannot directly use it, right? First, we have to see whether the information collected is correct, which is required for us, relevant. That process is called scrutiny of data. very important two terms that we have to remember with regard to scrutiny. Why do we do scrutiny? It is for checking whether the data is accurate and consistent. Right? These are the two terms that we have to remember: accurate and consistent, accuracy and consistency, whether the data is accurate and consistent. Now, are there any techniques for scrutinizing? The answer is no. It's purely dependent on the experience, the expertise, intelligence of the person who is scrutinizing the data. Now, what we can do, we have to check in we have to cross-verify the information, similar information given. If we have related information, then we can cross-verify. Right? So we can relate it to some related information. So if there are incomplete or erroneous information collected, ask the persons who have collected the information to recollect the data. Right? That is scrutinizing. Once we are done with scrutinizing, then the data that we have collected is raw. Right? So we have to classify them. We have to present them such that further analysis becomes easy. So classification. We have two different methods of classification: frequency group, non-frequency group. Under frequency, we have already learned this: qualitative data, quantitative data. Qualitative data is also called as ordinal data. Quantitative is also called as cardinal data, can be asked. Right? Instead of calling them qualitative, quantitative, they can call them ordinal, cardinal also in the exams. And second one is non-frequency. Under non-frequency, we have chronological data and geographical data. Chronological is time-based, geographical is region-based. Chronological data is also called as temporal data or time series data. Geographical data is also called as spatial data. Right? Geographical data is also called as spatial data. Then presentation. With regard to presentation, we have three types of presentation: textual presentation, tabular presentation, diagrammatic representation. Right? Textual presentation is presenting the information in the form of articles, paragraphs, etc. What is the disadvantage here? They are dull, monotonous, and comparison becomes difficult. Advantage is it is simple, no rule specific. We have to just present them in paragraphs. Whereas tabulation is the best method because it is accurate and attractive, right? And it facilitates comparison. Complicated data can also be presented. It is compulsory for diagrammatic representation and further statistical analysis. Whether we want to calculate simple arithmetic mean, we still want it in table, the data, right? So statistical analysis is not possible without tabulation. Till here, everyone understanding?
Yes, sir.
Yes. Yeah, this normally in statistics, what happens? 8 to 10 marks would be purely theory based. Okay, concept based. Just by looking into the question, subsequently, when we look into some of the questions, we'll understand. Just by looking into the question, we'll be able to identify the answer, provided we know these concepts. Right? So we have to spend some time here. Then we have guidelines of tabulation. Now, with regard to table, we have discussed parts of a table. Right? Every table should have a serial number. Table serial number. Then we will have title. Title should be crisp and short. However, if certain information have to still be further explained, which cannot be explained in title, it can be explained through
Subheading.
Head note, we call it. Correct? We call it head note. Then we have the body that where data is presented. Just above that, we can write unit of measurement, scale, etc. Now, in the body, the entire upper part of the table, including the units of measurement, is called box head. Right? Those column headings and column subheadings are called
Captions.
captions. So captions are included in box head. That is, box head includes captions. Correct? Then row headings are called
Stubs.
and the area where the data is presented, it's called the
Body of the table.
Body of the table. Then if you have any source or abbreviation, etc. to be brought
Footnote.
in, it can be brought in the form of footnote. That's all. These are the different parts of the table. Right? Certain specific points that we have to keep in mind. Table should be well balanced in length and breadth. and the comparison should be easy. The table should be presented in such a way that comparison becomes easy, and it should be in well-balanced sequence and presentation to be appealing. Footnotes having source of the data, etc., can be given at the bottom of the table. Okay, these are some of the guidelines. Parts of the table that we have. Parts of the table we have already discussed. Table number, title, caption is column heading, stub is row heading, body is contains the data, head note. Something that is not explained in the title, caption, stubs can be explained in the head note on the top of the table. Footnote, source of the data, some exception in the data can be given in footnote. Table under consideration should be divided into caption, box head, stub, and body. Caption is the upper part of the table describing columns and subcolumns. Box head is the entire upper part of the table, which includes columns, subcolumns, units of measurement along with captions. Stubs is the left part of the table providing description of the row. Body is the main part of the table that contains the numerical figures. Right? That's about tabular presentation. The last one under presentation, diagrammatic representation. The name itself says it is representation. So it is done for the second time. Presentation is done for the second time. So for a diagrammatic representation, tabular presentation is compulsory. Advantage here is it is attractive, right? We can get the hidden trend can be easily identified, and it can be used by both educated section and uneducated section in the society. Whereas disadvantages, it is less accurate when compared to tabulation. Why? Because we use scale. In a graph we use scale, so it might not be exactly the value that we want. However, what are the different types of diagrams that we have in this? Line diagram, bar diagram, and pie chart. Right? What happens in case of a line diagram? We would plot the values in the graph and join them using straight lines. That is line diagram. Join them using straight line. That is simple line diagram. However, if there are wide range of fluctuations, then instead of the normal line diagram, we use logarithmic or ratio line chart. Yes, logarithmic or ratio line chart. Then we have two different types of line diagrams: multiple line chart, multiple axis line chart. Right? These small concepts important can be asked. The multiple and multiple axis both are used when we have 2 time series data or more than 2 time series data. Now, multiple line chart will be used when those time series have same units. Multiple axis will be used when they have different units. When they have different units. Is that clear?
Yes, sir.
Yes. Okay. So that's the different types of line diagram. Next one, bar diagram. Bar. In case of a bar diagram, we have rectangular bars to represent the data, right? Instead of line diagram. So what do? We bring in rectangular bars for each specific item given in the question, and accordingly present the bar diagram. Bar diagrams are of 2 types: horizontal bar diagram, vertical bar diagram. Now, horizontal bar diagram and vertical bar diagram, which will be used when? Easy to remember. Normally, we have vertical bar diagrams. Normally, in statistics, we have quantitative data. So, vertical bar diagrams are used for quantitative data. Right? Vertical bar diagrams are for quantitative and time series, that chronological data. These are the 2 commonly used data in statistics. Horizontal, very rarely used. Qualitative data. And what was the other one in the different modes of presentation? Spatial or geographical. Correct. Spatial or geographical data. Right? So this is how it is used. Now, we have normal bar diagrams like this, simple bar diagrams. Instead, if we have multiple data, in case of line diagram, we have 2 types: multiple line chart, multiple axis line chart. Right? Here, irrespective of whether they are of same units or different units, we can present it similarly. In case of a bar diagram, we have multiple bar diagrams. That is, for the same year 2009, if we have production of rice and wheat, both will be brought as adjacent bars. That is multiple bar diagrams. However, if I do not want multiple, I want one single bar, but inside that we will have bifurcation. This is rice and this is wheat. We call it
Component bar diagram.
Subdivided.
component bar diagram or subdivided bar diagram. Yes, here in the case of component or subdivided, I go with the actual quantity, right? However, if I do not want actual quantity, I want to express them in percentage. I'll have one single bar, but calculate the percentage of composition and divide them. That is percentage or divided bar diagram. Percentage or divided bar diagram. Okay, these are the different types of bar diagrams that we have. Horizontal bar diagram, vertical bar diagram, multiple or grouped bar diagram, component or subdivided bar diagram, divided bar charts or percentage bar diagram. Third one that we have is pie chart. Now, in case of pie chart, the point that we have to keep in mind is we have to convert the given data into central angles. What is the total sum total of all the angles in a pie chart?
360 degree.
Because pie chart is represented in the form of circle. Correct? So we have to convert all the required given information into these central angles by considering the maximum as 360 and then present it in the form of pie chart. Calculation of the central angle can be asked in the exam. Okay, so only that conversion into angles can be asked in the exam. That's all. This is diagrammatic representation. So with this, presentation is done. Till here, everyone clear?
Yes, sir.
Yes.
Yes, sir.
Yes. Next one, important discussion, frequency distribution. Now, we all know what is frequency. Frequency is the number of times it has repeated, correct? Yeah. Now, if we present the data in such a form, bringing the values, observations, and its frequency, that is frequency distribution. We can have two different types of frequency distribution. If it is a discrete variable, the frequency distribution that we get is discrete frequency distribution. If it is a continuous variable, we get continuous frequency distribution. Right? Now, what are the steps in case of construction of frequency distribution? First, we should know what is the minimum and maximum value. So first, we shall calculate the range. First step is calculation of range. Identify the minimum and maximum, calculate the range. Then calculate number of class intervals. How do we calculate number of class interval? Range divided by
Width of
the class interval. Range by size of the class interval. Size depends upon the requirement. Once we have this, we know the number of class intervals. So present all the class intervals in the form of a table. Then we start allotting the frequencies. How? By applying
tally marks.
Tally marks. We apply tally marks and allot. Once all the observations are done, then count the number of tally marks corresponding to each class interval. That would be the frequencies of that class interval. Right? These are the steps. We shall identify the largest and smallest observation, obtain the range, number of class intervals, present the class intervals in a table, count the tally marks and present these numbers in the next column known as frequency column. Check whether the total of these class frequencies tally with the total number of observation. That is how we get the frequency distribution. Once we get the frequency distribution, there are certain specific information which are very important there. First one, class limit. Class limits are the extreme observations, right? So upper limit and lower limit. For every class interval, we shall have the upper limit and lower limit. Irrespective of whether that class is mutually inclusive or mutually exclusive, the class intervals lower and upper value itself will be the class limits. So if we have 0 to 10, 10 to 20, 20 to 30, mutually exclusive information, lower class limit is 0, upper class limit is 10. Or if we have 0 to 9, 10 to 19, 20 to 29, mutually inclusive class intervals, still lower class limit is 0, upper class limit is 9. Right? That is class limits. However, class boundaries. In case of mutually exclusive, we don't have the confusion with regard to class limits and class boundaries because class limit is equal to class boundary. Whereas in case of mutually inclusive, what if I get 9.3? In which class interval I should have to assign? For that, we should know the real limits of the class interval. Even though class limits are the limits of the class interval, they are not the real limits. So class boundaries are the extreme values of the class limits. They are the real boundaries. How do we get that? Identify the difference between these two. Lower limit of the next class interval, upper limit of this class interval. Here we have 1, divide by 2, 0.5, apportion it to both. That is, to get the lower class boundary, subtract that d by 2 from the lower limit, we get minus 0.5. To get the upper class boundary, add that d by 2 to the upper class limit, 9 plus 0.5, 9.5. 10 minus 0.5, 9.5. 19 minus 0.5, 19.5. 20 minus 0.5, 19.5. 29 plus 0.5, 29.5, and so on. These are the class boundaries. These are lower class boundaries. These are upper class boundaries. Understood?
Yes, sir.
Yes, sir.
So these are class limits and class boundaries. Minimum value is LCL, maximum value UCL. Lower limit to LCL is LCB, upper limit to UCL is UCB. Right? For mutually exclusive, UCL and upper class limits and upper class boundaries are the same. That is, class boundaries coincide with class limit. For non-mutually exclusive, we'll have different class boundaries and class limits. How do we calculate it? Lower class boundary is lower class limit minus d by 2. Upper class boundary is upper class limit plus d by 2. D is the difference between lower class limit of next class interval, upper class limit of this current class interval. Then we have midpoint. The next discussion is midpoint. For calculation of midpoint, we can either take class limits or class boundary. It doesn't make any difference. So if we are taking class limit, upper class limit plus lower class limit divided by 2. If you are taking class boundary, upper class boundary plus lower class boundary divided by 2. Right? It's called the representative of that particular class interval. Midpoint LCL plus UCL by 2 or LCB plus UCB divided by 2. In case of calculation of arithmetic mean, when we have class intervals, that value of x that we take, it is the midpoint. Right? Then length of the class interval, the number of values that particular class interval takes. How do we calculate the length? We should always take the difference of class boundaries, not class limit. To get the length or width of the class interval, it is UCB minus LCB, not UCL minus LCL. Right? For midpoint, no such restriction. But for class length, there is a restriction that it should be difference of class boundaries. Then cumulative frequency. Now, as the name itself says, cumulative, we shall go on adding that particular frequency, add up, aggregate, right? Frequencies. Now, if I want to know the number of observations which are less than 30, what should I do? I should add up the frequency of 1, 2, and 3 class intervals. Right? Since this cumulatively represents the number of observations less than 30, we call it less than cumulative frequency. Less than cumulative frequency. How do we get less than cumulative frequency? Add up the frequencies from the beginning. From the beginning, if you add up the frequencies, we get less than cumulative frequency. However, if I want to know the number of observations more than 0, then I have to add up 1, 2, 3. If we have 30 to 40, 40 to 50, I have to add up all these frequencies greater than 0 number of observations. Now, if I add up all these, since I am considering number of observations greater than 0, that represents more than cumulative frequency. So to get more than cumulative frequency, start from the last. Add up all the frequencies from the last. We get more than cumulative frequencies for each class interval. Right? This is about cumulative frequency. Number of observation less than the value, less than equal to the class boundary. So in case of cumulative frequency, whenever we are comparing, we have to compare class boundaries. Less than cumulative frequency means less than the upper class boundary. More than cumulative frequency means more than the lower class boundary. Then next three discussions, simple discussions. We have frequency density, relative frequency, and percentage frequency. Frequency density, relative frequency, and percentage frequency. Frequency density focuses only on that class interval. It is not bothered about other class intervals. So frequency of that class divided by that class size. No, not total frequency. Frequency density only focuses on that class interval, right? Frequency of that class divided by class size. Whereas relative frequency is frequency of that class divided by total
frequency.
Yes. Frequency of that class divided by total frequency. If I express the same in terms of percentage, it is percentage frequency. If I express relative frequency in percentage, so frequency density may be defined as ratio of frequency of that class interval to the corresponding class length. Frequency density for the first two class intervals. Okay, these are in our example. Okay, right. Relative frequency and percentage frequency. Relative frequency of a class interval may be defined as ratio of class frequency to total frequency. Percentage frequency of a class interval may be defined as ratio of class frequency to total frequency expressed in percentage. These are the different concepts that we had to learn in case of frequency distribution. Till here, everyone understood?
Yes, sir.
Yes, sir.
Yes. If we have understood this, then we'll move on to the last part of this chapter, which is graphical representation of frequency distribution. Here we have four concepts. One, histogram. Second, frequency polygon. Third, ogives. And the last one, frequency curve. Correct? Histogram extension of bar diagram, we use rectangular bars. But the difference between histogram and bar diagram, we use adjacent bars here. Unlike bar diagram, we use adjacent bars here. And second one, for the purpose of histogram, we will use class boundaries. We will use class boundaries, not class limits. Right? These are the two important points. Histogram idea of the frequency curve, comparison between different class intervals is possible. To draw histogram, class limits are converted to class boundaries and a series of adjacent rectangles, one against each class interval, will be drawn. Adjacent rectangles. These are the two important concepts here. Then, by drawing histogram, there is one measure of central tendency that I get.
Mode.
Yes, by intersecting the topmost extreme points of the tallest rectangular bar, we get the value of mode, the intersecting point, right? So that helps, that gives us mode. Next one, frequency polygon extension of line diagram. We plot the frequencies in the graph, join it to straight lines. However, we will give it form of a polygon by connecting the extreme points to the x-axis. Left-hand side, we connect it to 0. Right-hand side, we connect it to the next value in the x-axis. So that we get the value of, we get the form of a polygon. It is meant for single frequency distribution. We can also apply it for group frequency. However, width of the class interval should be the same. In case of histogram, no such restriction. Width of the class interval can be different. But here, width of the class interval should be the same. Now, in case of histogram, we were using class boundaries. In case of frequency polygon, since it is a point, we cannot have class limits or class boundaries to be used. We have to use midpoint. Right? We have to use midpoints. In case of frequency polygon, we shall use midpoints. The next one, ogives, or cumulative frequency graph. Why it is called cumulative frequency graph? Because we use cumulative frequencies. Right? Since we have two types of cumulative frequencies, less than cumulative and more than cumulative, we have two types of ogives. Less than type ogive, more than type ogives. Now, ogives, once we have the ogives marked, see, it is similar to line diagram. However, once we have plotted the cumulative frequencies in the graph, we use freehand curve to connect them, not straight lines. Right? We use freehand curves. Now, using ogives, we can calculate quartiles. Q1, Q2, Q3. So we can calculate median with the help of less than cumulative frequency ogive. However, if we have both less than cumulative and more than cumulative, very easily we can calculate median. How?
Intersection of both.
Yes, intersection of both less than and more than type ogive. From that particular point, draw a line perpendicular to x-axis. The point intersecting to the x-axis would give us the median, or Q2. Right? That is about ogives. And the last one, frequency curve. In case of frequency curve, no straight lines, we will be drawing smooth curve. And we will not consider either the frequencies nor cumulative frequencies. Instead, we convert frequencies by considering the total area as one unity. Basically, we will be calculating relative frequency. We will be calculating relative frequency and applying that relative frequency in the frequency curve. Using histogram, we can get frequency curve. How? By joining the midpoints of each rectangular bar with a freehand curve, we get frequency curve. Right? We have different types of frequency curve, 4 types. Bell-shaped curve, it will be in the form of a bell. So the observations are maximum at the middle and they are minimum at the two extremes. U-shaped curve, observation is minimum at the middle, maximum at the two extremes. J-shaped curve starts with the minimum value, ends up with the maximum value. Inverted J-shaped curve start with the maximum value, end with the minimum value. Mixed curve can have any of the above characteristics in combination. Right? These are the different types of frequency curve. Everyone understood?
Yes, sir.
With this, we are done with the first chapter. First chapter on statistical description of data. Now, what we can do is, instead of directly moving on to discussing some of the questions, we will finish the second chapter also. We'll discuss the questions of first or look into the questions of first and second chapter together. Okay. So, what is the second chapter? Very important chapter in statistics. Right? Measures of central tendency and dispersion. It has 2 parts, measures of central tendency and measures of dispersion. First, we have central tendency. What is central tendency? It is the tendency of all the observations to cluster around that central value. How do we find out that central value? We have measures of central tendencies. 5 measures: mean, median, mode, geometric mean, harmonic mean. So there are various criteria to consider the ideal measure. These are relevant for us to analyze each measure of central tendency to identify what are the advantages and disadvantages. First one, should be properly and unambiguously defined. There should not be ambiguity. It should be rigidly defined. Then it should be easy to compute. It should be simple to calculate, easy to comprehend, simple to compute. Should be based on all the observations. Should have certain desirable mathematical characteristics. Should be least affected by presence of extreme observations. So all these points we'll be discussing individually in each of the measures of central tendency. Correct? First one, arithmetic mean, sum of all the observations divided by the number of observation. For ungrouped data, we have summation x by n. For grouped data,
Summation fx by
summation fx by n. Correct. For ungrouped data, we have summation fx by n. However, alternatively, we have a shortcut method that we have discussed, A plus summation FD by N into C. Right? If we have large values of X, instead of multiplying it with the F to get large Fx values, what we can do, we can assume a mean, assumed mean A. It can be any value, right? It need not be the values in the given range. It can be any value. However, for ease of calculation, preferably consider one of these X values, that to middlemost value, so that it will be easy for calculation. From that, calculate D. How do you get D? X minus A by C. C is the class length of that class interval. From that, you get D. Once you have D, normal arithmetic mean calculation, multiply this with F. So calculate F into D, sum total, summation FD. Normal formula is summation Fx by N. So here also you do summation FD by N. But I do not want arithmetic mean of D values. I want arithmetic mean of X values. How did you get D value? By subtracting A and dividing C, reverse it, multiply C, add A. You get the arithmetic mean for X values. A plus summation FD by N into C. It's the shortcut method for calculating arithmetic mean. Correct? So these are the three formulas in arithmetic mean. But more than calculation of arithmetic mean, properties of arithmetic mean are very important. We have only 4 properties. First one, if all the observations are constant, arithmetic mean is that constant. If all the observations are 5, 5, 5, 5, 5, arithmetic mean is also 5. Second one, algebraic sum of deviations of the arithmetic mean, or deviation of the observations from arithmetic mean is always 0. That is, for unclassified, ungrouped data, summation x minus x bar is 0. For grouped data, summation f into x minus x bar is 0. Right? Very important concept. They can ask practical question. They can ask you to find out the sum of deviations for the following observations. There we need not calculate. We have to directly tick the option 0. Third one, with regard to change of origin and change of scale. Change of origin is addition or subtraction. Change of scale is multiplication, division. Arithmetic mean gets affected by both change of origin and change of scale. Therefore, if y is equal to a plus b into x, y bar is equal to a plus b into x bar. Right? Lots of questions will be asked on this, based on this in the exam. Last one, combined arithmetic mean. If we have two observations, two groups of observations with n1 and x1 bar, n2 and x2 bar, how do we calculate combined arithmetic mean? n1 x1 bar plus n2 x2 bar divided by n1 plus n2. If we have more than 2 observations, we have to just add up, right? In the numerator as well as denominator. So as a common formula, we can have summation ni xi bar divided by summation ni, where I represents 0 to n, depending upon the number of observations that we have. This is arithmetic mean. Next one, we have median. Median is a positional average. Why? It is not a derived figure. It is a position in the given observation. It's the middlemost value, right? It's the middlemost value when the observations are arranged in ascending or descending order. So in case of ungrouped data, how do we calculate median? Simple. We have to just arrange them in ascending or descending order, identify the middlemost value. If we have even number of observations, then we'll have 2 middle values, take the average. In case of discrete observation, it is simple. Discrete data, if we have 0, 1, 2, 3, 4, if we have the observations, total of the observation, calculate cumulative frequency, total of the observation, n divided by 2, locate where n divided by 2 falls, right? Using the help of cumulative frequency column, that particular value of x represents the median. That particular value of x represents the median. That is in case of discrete. However, in case of continuous frequency distributions, we have this formula to calculate median. L1 plus n by 2 minus nl divided by nu minus nl into C. So for this, first you have to identify the median class. That is the class interval where median falls. How do we do that? They would have given us class interval and frequencies. We have to find out cumulative frequency. Now we have n divided by 2. Find out in which class interval n divided by 2 falls. That is the median class. L1 is the lower class boundary of that median class, not limit, lower class boundary of that median class. N by 2 we already have. NL is the cumulative frequency
Of the
corresponding
median
to the
class.
preceding pre-median class. NU is the cumulative frequency of the median class. Correct? NU, and C is the width of the median class. If we have this information, we can calculate median by applying this formula. Clear? That is how do we calculate. Coming to the properties. First one, change of scale and change of origin, same concept, gets affected by change of scale and change of origin. So if we have y is equal to a plus b into x, median of y will be equal to a plus b into median of x. Then second important property for a given set of observation, if we are taking sum of absolute deviations of that observation, not the deviation, we are taking absolute deviation, modulus of it. If we take absolute deviations of the observation, such deviations are minimum if the deviations are taken from median. If the deviations are taken from median, right? These are the two properties in case of. Now, as a continuation of median, we have partition values. Basically, what are partition values? They divide the observations into equal parts. Right? They divide the observation into equal parts. So if we have 2 equal parts, we call it as median.
Median.
4 equal parts,
Quartile.
so we have 3 quartiles. 10 equal parts,
Deciles.
deciles. We have
9
9 deciles. Correct? Yes.
Yes, sir.
Yes. 100 equal parts,
Percentile.
Percentiles.
we have 99 percentiles. Now, in case of ungrouped data, first you arrange it in ascending order, then calculate n plus 1 into pth value. P depends upon what you want. If you want Q3, it is 3 by 4. If you want D6, it is 6 by 10.
6
If
by
it is
10.
P36, that is 36 by
36 by
36 divided by 100.
correct. N plus 1 into pth value, locate that in the ascending order that you have brought in the sequence. That will give us the required partition value. Now, if we want 7.6th value, how do we get 7.6th value?
Seventh
7th value
plus
plus
0.6 plus 8 into 8 minus 7th value.
0.6 into 8th value minus 7th value. Correct? This is how we get 7.6th value. Right. That is in case of ungrouped data. In case of grouped data for discrete distribution, it is still the same. Calculate n into p, n into pth value. That is, p depends upon what you want. Q3 means 3 by 4, p5 means 5 by 100, d7 means 7 by 10, and so on. Right? And locate it in the frequency distribution that we have. However, in case of continuous distribution, our first step is to identify the class interval in which that partition value falls. How do we do that? Again, calculating NP. By calculating N into P, by using cumulative frequency, we will first locate where that particular quartile or decile or percentile falls. Once we have that, we have the same formula that we have used for median. L1 plus, instead of n by 2, we use NP here. Because in case of median, it was always n by 2. Here it can be different. Since we have different quartiles, deciles, and percentiles, we use NP minus NL divided by NU minus NL into C. NL, NU remains the same. The concept of NL and NU remain the same. Another way of finding out these partition values are quartiles are using ogives. We have discussed less than type ogive. Right? What should we do? We should draw a parallel line to the horizontal axis through the point NP. We have to locate the point NP in that particular graph and draw a parallel line through the ogives to the x-axis. That value is the required quartile. Right? That is how we draw graphically. That is partition values. Then we have the next measure of central tendency is mode. The value that occurs the maximum number of times is called mode. Correct? Mode. How do we calculate? In case of ungrouped data, easy. We have to just identify which has the maximum, which is maximum repetition. In case of discrete data,
Number of
simple.
maximum frequency.
Highest frequency. That particular value of X is the mode. In case of continuous data, we'll discuss. Okay, value which has maximum concentration of observation around it. A distribution can have more than one mode. If we have more than one mode, we call it multimodal distribution. However, certain cases distribution can have no mode as well. In case of continuous frequency distribution, first job is to identify the
Modal class.
class interval in which mode falls. How do we identify the class interval having the highest frequency? Is the modal class. Once you identify that, this is the formula. L1 plus F0 minus F minus 1, not F1. F0 minus F minus 1 divided by 2 into F0 minus F minus 1 minus F1 into C. Here F0 is the frequency of the modal class. L1 remain the same, lower class boundary of the modal class. F0 is the frequency of the modal class. F minus 1 is frequency of pre-modal class. F1 is frequency of post-modal class. Simple. With regard to properties, the only one property that we have to keep in mind, change of origin, change of scale. Mode also gets affected by change of origin, change of scale. So y is equal to a plus b into x, mode of y is equal to a plus b into mode of y. Now, with regard to these three, mean, median, and mode, we have one empirical relationship, very important, right? Normally, one question will be asked from this. Mean minus mode is equal to 3 times mean minus median, or mode is equal to 3 median minus 2. So this is the empirical relationship, which is important. We have to remember. So these are the three measures that we have discussed. What are the three measures that we have discussed? Mean, median, and mode. Clear till here?
Yes, sir.
Yes, sir.
Yes. Once we have this, we'll move on to the next discussion. Which is geometric mean. Geometric mean is nth root of the product of the observations, right? Depending upon the number of observations, that root, nth root of the product of the observations. So x1 into x2 into x3 into up to xn to the power of 1 by n, or for grouped frequency, x1 to the power of f1 into x2 to the power of f2 into x3 to the power of f3 up to xn to the power of fn to the power of 1 divided by n, capital N. Here, calculations, simple calculation can be asked. They can give us 1, 2, and 3 and ask us to calculate geometric mean, etc. Simple calculations, not more than 4th root. 4th root we can calculate by pressing square root twice. Correct? Cube root, normally easy calculations will be asked. Cube root can be asked. Square root, anyhow, we all know how to calculate square root, right? So simple calculations, but more importantly, properties of geometric mean. Very, very important. Logarithm of a geometric mean for a set of observation is arithmetic mean of logarithm of the value, observations. That is, log of geometric mean will be first calculate log values, then calculate arithmetic mean of it. Summation log x by, instead of n, they use r. Summation log x by r. Right? Logarithm of geometric mean is arithmetic mean of logarithm of the observations. Second one, we all know if all the observations are constant, geometric mean is also that constant. Third property, if we know z is equal to x into y, geometric mean of z will be equal to geometric mean of x into geometric mean of y. If z is equal to x divided by y, geometric mean of z is equal to geometric mean of x divided by geometric mean of y. Disadvantage, it is most difficult to calculate if the number of values are more. Clear? That is geometric mean. Harmonic mean. The definition of harmonic mean says it is defined as reciprocal of arithmetic mean of reciprocal of the observations. If we have ungrouped data, n divided by summation 1 by x will give us harmonic mean. How to calculate? We have x values. First calculate 1 by x values, add up everything. We know the number of values, so n divided by summation 1 by x. However, if we have group data, capital N divided by summation f by x. So we have x and f values. Even if we have class intervals, calculate x values, x and f, calculate f divided by x. In arithmetic mean, we were doing f into x. In harmonic mean, we do f divided by x, add up this summation f divided by x. Then we all know summation f is n divided by summation f divided by x, we get harmonic mean. Okay, so this is how we calculate for ungrouped data and grouped data. Understanding? Here as well, more than the calculation, properties become important. If all the observations are constant, harmonic mean is that constant. How do we calculate combined harmonic mean for two observations? Normally, not more than two, they'll ask. N1 plus N2 divided by N1 by H1 plus N2 by H2. This is very important. N1 plus N2 divided by N1 plus H1 divided by N2 plus H2 is how we calculate harmonic mean. Clear? Now, properties of AM, GM and HM, at any point in time, arithmetic mean is greater than or equal to geometric mean is greater than or equal to harmonic mean. More importantly, this is very important. Geometric mean is equal to square root of arithmetic mean into harmonic mean, or G square is equal to A into H. That empirical relationship between mean, median and mode, and this relationship between geometric mean, harmonic mean and arithmetic mean, very, very important. Okay. So after that, we have some small discussions. Weighted average. Instead of frequencies, we use weights. Instead of ES, use W. Weighted arithmetic mean is summation WX by summation W. Weighted geometric mean is anti-log of summation W log X by summation W. Weighted harmonic mean is summation W by summation W by X. Instead of F, we are using W. That's all. There is no other difference between weighted and normal frequency distribution and weighted frequency distribution. Now, when do we use arithmetic mean, geometric mean, harmonic mean? Important. Arithmetic mean is the commonly used average. Geometric mean are normally used for rates and percentages. Whenever they give us rates and percentages, we have to use geometric mean. Harmonic mean is for average speed, average of speed, right? Whenever they give us speed related information, we use harmonic mean. In all other cases, we use arithmetic mean. Now, what are the comparisons? The best measure of central tendency is arithmetic mean. Arithmetic mean is rigidly defined. The criteria that we had rigidly defined. It is based on all observations, easy to comprehend, simple to compute, and it is amenable to mathematical properties. The only drawback that it has is it gets affected by sampling fluctuation, and mean cannot be calculated for open-ended classification. What are open-end class intervals? If the first class interval does not have lower limit, less than 10. If the last class interval does not have upper limit, 0 greater than 100. These are open-ended class intervals. In such case, I cannot calculate midpoint. Therefore, no calculation of arithmetic mean, not possible. Then, in case of median, like arithmetic mean, median is also rigidly defined. It is easy to compute and comprehend. But disadvantage, median is not based on all observation. Very important disadvantage. And it does not allow itself to mathematical treatments. Doesn't allow itself to mathematical treatments. However, advantage, median is not much affected by sampling fluctuation. And median is the most appropriate measure in case of open-ended class intervals. Can be asked, which is the best measure for open-end class intervals? Median. Next, mode. Mode is the most popular measure of central tendency. There are cases when mode remain undefined. There's a disadvantage, right? It is not unambiguously defined. There are chances that mode remain undefined. There are chances that we have multiple modes. Unlike mean, no mathematical properties. And mode is also affected by sampling fluctuations. However, coming to geometric mean and harmonic mean, they have mathematical properties. they are rigidly defined and based on all observations. But what is difficulty? Difficult to comprehend and difficult to compute. But they're difficult to comprehend and compute. And as such, limited applications for computation of average rates and ratios and such like things. So they are very limited applications. Geometric mean and harmonic mean. That's all. This is about measures of central tendency. Is that clear? Yes. Now the last part of this chapter, we'll move on to measures of dispersion quickly. The second important characteristic of a distribution is given by dispersion. What is the first important characteristic?
Central.
Yes. Central tendency. Now, what is dispersion? Dispersion is the deviation of the observation from central tendency. Even though we say they cluster around the central value, they do not become the central value. They are different values itself. They cluster around. What is the amount of difference? What is the amount of deviation? That is measures of dispersion. We have two measures of dispersion: absolute measure, relative measure, range, coefficient of range, mean deviation, coefficient of mean deviation, quartile deviation, coefficient of quartile deviation, standard deviation, coefficient of standard deviation, or coefficient of variation. What is the difference between absolute measure and relative measure? Absolute measure dependent on unit of measurement, whereas relative measure is unit free. Comparison between two distributions might be difficult under absolute measure. However, it is possible under relative measure. However, absolute measure is easy to compute and comprehend. Relative measure is difficult to compute and comprehend. What are the characteristics for an ideal measure of dispersion? Same 6 characteristics that we have discussed in case of central tendency, right? It should be properly defined, comprehend, compute based on all observations, unaffected by sampling fluctuation, and amenable to some desirable mathematical treatments. Then, first measure that we have, range. We all have already discussed this. Maximum value, minimum value, difference. Right? The difference between the largest and smallest of the observations. Thus L and S denote largest and smallest. So L minus S. Coefficient of range is L minus S divided by L plus S into 100. In case of ungrouped data, easy. We can identify largest value, we can identify smallest value. In case of group data, if it is discrete, again, we can identify largest value and smallest value of X. If it is continuous, go with class boundaries. Lower class boundary of the first class interval is the lowest value. Upper class boundary of the last class interval is the highest value. Highest value minus lowest value will give us the range. Okay. For grouped frequency distribution, range is defined as difference between two extreme class boundaries. The corresponding relative measure is how do we get coefficient of range in case of group frequency distribution? Same. We have class boundaries computed, right? Ratio of difference between the two extreme class boundaries to the total of these class boundaries expressed as percentage. The disadvantage, it is not based on all observations. Since range is based only on 2 observations, it is not regarded as an ideal measure of dispersion. That is range. Property with regard to change of origin and change of scale. In case of measures of central tendency, all measures of central tendencies were getting affected by both change of origin and change of scale. In case of dispersion, they will not get affected by change of origin, but will get affected by change of scale in the same proportion. Therefore, if they have given us range of X, and if they have given us Y is equal to A plus B into X, range of Y will be equal to modulus of B into range of X. Range of Y is equal to modulus of B into range of X. Again, these are important. Can be asked. Next one, mean deviation. When compared to range, this is a better measure. Why? Because it is based on all the observations. For a given set of observation, mean deviation is defined as arithmetic mean of absolute deviations of the observation from appropriate measure of central tendency. Now, mean deviation can be taken from arithmetic mean, median, mode. Correct? Therefore, we don't have a standard formula. Instead, a general formula, summation modulus of X minus A divided by N. So we always take the absolute deviation, modulus of X minus A. This A can be arithmetic mean, median, mode, geometric mean, or harmonic mean. Right? So modulus of summation x minus a by n for grouped modulus summation f into modulus of x minus a. Summation f into modulus of x minus a divided by n. That is how we calculate mean deviation. Mean deviation about mean if a is taken as mean, mean deviation about median if a is taken as median. Its relative measure is coefficient of mean deviation divided by a into 100. If we had taken mean, mean deviation by mean. If we had taken median, mean deviation by median into 100. Simple. Then properties of mean deviation. Mean deviation, in case of median, we had discussed absolute deviations are minimum when it is taken from median. Here, what are we taking? We are taking absolute deviation, modulus of x minus a. So, mean deviation is minimum when the deviations are taken from median. When the deviations are taken from median. Same concept of change of scale and origin doesn't get affected by change of origin, but gets affected by change in scale. Therefore, if y is equal to a plus b into x, if they have given us, if we want mean deviation of y, mean deviation of y will be modulus of b into mean deviation of x. Although it is an improvement over range because it's based on all observations. What is the disadvantage? It is difficult to compute. Moreover, why it is difficult to compute? Which measure we have to consider? Whether we have to consider mean, median, or mode. Selection of that itself is it's a decision that we have to make. Then it cannot be treated mathematically. No mathematical properties. Next one, standard deviation, the best measure of dispersion. In measures of central tendency, we have arithmetic mean. Here we have standard deviation. Right? The best measure, standard deviation does not possess the demerits of range and mean deviation. Now it is root mean square deviation when deviations are taken from arithmetic mean. We can calculate standard deviation in case of ungrouped data, summation x minus x bar the whole square by n square root, or summation x square by n minus summation x by n the whole square, or x bar the whole square. This can also be written as x bar. In case of grouped data, root of f into summation f into x minus x bar the whole square divided by capital N. F should be inside a summation. Then, or it can also be calculated by summation fx square by capital N minus summation fx by capital N the whole square. Instead of this, we can also write it as x bar. Right? This is the formula to calculate standard deviation. Variance is square of the standard deviation. Now, it's the most useful measure of dispersion and most commonly used. It has some desirable properties. We can also calculate combined standard deviation. How do we calculate? We will discuss. Its relative measure is coefficient of variation, standard deviation by arithmetic mean into 100. Coefficient of variation. Now, in arithmetic mean, we had an alternative method. Similarly, we have alternative method of calculating. Instead of x, consider d. Same. So, square root of summation fd square by n minus summation fd by n the whole square. Here, what is d? Same, x minus a by c. Okay, so for large values of x, we can still use this alternative formula. If all the observations are equal, then what is standard deviation?
The value.
0. There is no deviation at all. Right? So if all the observations are equal, standard deviation is 0. This holds good for range and mean deviation also. When all the observations are equal, in case of measures of central tendency will be that observation itself, that constant itself. Whereas if all the observations are equal in case of measures of dispersion, no deviation, so it's 0. Measures of dispersion is 0. Then standard deviation gets affected by change of scale, but not by change of origin. Therefore, if y is equal to a plus b into x, standard deviation of y is modulus of b into standard deviation of x. If there are two groups containing n1 and n2 observation, x1 bar and x2 bar are the arithmetic mean, s1 and s2 are the standard deviation, we get combined standard deviation using this. Square root of n1 s1 square plus n2 s2 square plus n1 d1 square plus n2 d2 square divided by n1 plus n2. Here we all know what is S1 and S2. What is D1? What is D2? We get D1 by considering X1 bar minus combined arithmetic mean. D2 is X2 bar minus combined arithmetic mean. Right? However, if we have combined X1 bar and X2 bar equal, in that case, combined arithmetic mean also be equal to the X1 bar and X2 bar, then we will not have D1 and D2. So in that case, it will only be summation N1 S1 square plus N2 S2 square divided by N1 plus N2. That is how we calculate combined standard deviation. Next, we have quartile deviation, the last concept. Quartile deviation provides for the best measure of dispersion for open-end class interval, similar to median. Median, we had best measure of central tendency for open-end class intervals. This is the best measure of dispersion for open-end class interval. It is less affected due to sampling fluctuation, and disadvantage not based on all the observations. Right? And it doesn't get affected by change of origin, but does get affected by change in scale. Therefore, if y is equal to a plus b into x, quartile deviation of y is modulus of b into quartile division of x. How do we calculate quartile deviation? Q3 minus Q1 by 2. Simple. We have to just have Q3 and Q1. Since it is Q3 minus Q1 by 2, it is also called a semi-interquartile range. Correct? Relative measure is coefficient of QD, Q3 minus Q1 by Q3 plus Q1 into 100. Easy to remember. In case of range, we have L minus S, largest minus smallest. So coefficient of range is L minus S by L plus S. In case of QD, Q3 minus Q1 by 2. So its coefficient is Q3 minus Q1 by Q3 plus Q1. Okay. And in case of standard deviation and mean deviation, it is mean deviation by that particular measure of central tendency into 100. In case of standard deviation, it is standard deviation, we always use arithmetic mean. So that measure of central tendency is arithmetic mean into 100. So this is how we can remember easily the different measures of relative measures of dispersion. That's all. These are the different measures of dispersion that we have. So with this chapter, we have in detail discussed about measures of central tendency and measures of dispersion. Till here, everyone understood?
Yes, sir.
Yes, sir.
Okay, fine. So if we are done with this, before moving on to the next chapter, we'll look into some of the questions from the first two chapters. Okay. So with regard to questions, CAPS material problems we have already solved. Study material problems are similar to CAPS material. So what I have done is, I have compiled last 6 attempts mock test papers. Okay. The mock test papers of 6, which is there in the revision material itself. So we will discuss the questions from those mock test papers. Okay, if we come to that particular page, mock test paper 1, the first paper that we have is March 2021, right? So here in mock test papers, they'll have the questions arranged in order itself. Okay, first they have mathematics, then they have logical reasoning and statistics. In exams, it need not be the case. In exams, no such order, it will be jumbled. Questions would be jumbled. First question can be of statistics, second question can be of logical reasoning, third question can be of mathematics. So no such structure as such, but here for our ease of understanding, they have given us the structure. Okay, we'll move on to the statistics part. Question number 61. From question 61, we have statistics. Yes. First question. Histogram is used for presentation of the following types of series.
Continuous.
Continue.
Very good. Continuous. Histogram, frequency polygon, ogives are all graphical representation of frequency distribution. Frequency distribution comes into picture in case of continuous. Right? So it is continuous frequency series. Graphical representation of cumulative frequency distribution.
Ogives.
Correct. Ogives. So if they have given us number of accidents and frequencies, they're asking us in how many cases 5 or more accidents have occurred.
54.
Correct. More than 5 means 5 plus 6 plus 7, right? So 27, 5, 18, 6 and 9, 7. So 27 plus 18 plus 9, 54. Understanding?
Yes, sir.
Simple questions, right? These kind of questions can be as simple. Difference between upper limit and lower limit of a class.
Class interval.
Class interval, right? So these are the 4 questions from the first chapter which was asked. Next, from the second chapter. A man travels at a speed of 20 kilometers per hour and then returns at a speed of 30 kilometers per hour, average speed.
km per hour.
No. If we write 25, we get minus 0.25. In case of speed, what is the measure of central tendency that we have to use?
Harmonic mean.
Harmonic mean. Harmonic mean is n1 plus n2 or rather, sorry, n divided by summation 1 by x. Correct? Here n is 2. One is traveling to a particular place, returning from that particular place. So 2 divided by 1 plus 1 by 20 plus 1 by 30. 1 by x. X is 20 and 30. 1 by 20 is 0.05. 1 by 30 is 0.033. Correct? So 2 divided by 0.083333, we get 24 kilometers per hour. Right? So in case of speed, compulsorily we have to use harmonic mean. Done? Next question. Sum of squares of the deviations of set of observation has the smallest value when the deviations are taken from there.
Arithmetic mean.
Arithmetic mean.
Arithmetic mean. We didn't revise this concept. Squares of the deviation has the smallest value, that is summation x minus x bar the whole square, right? So this is lowest when that deviation is taken from that arithmetic mean when compared to the other measures of central tendency. If two variables x and y are related by 2x plus 3y minus 7 equals 0 and mean deviation about mean of x are 1 and 0.3 respectively, coefficient of mean deviation of y about mean. Read the question carefully. In exams also, make a habit of reading the question twice at least, okay, before answering. Yes, we have shortage of time. We will have limited time, but we can afford to read it twice.
Set 12, sir.
Yes. So whenever they give us such equations, what should we do? We should express it in the form of y is equal to a plus b into x. Correct? So 2x plus 3y minus 7 is equal to 0 can be expressed as 3y is equal to, if I send 2x minus 7 the other side, minus 2x plus 7, or y is equal to minus 2x plus 7 divided by 3, or y is equal to minus 2 by 3x plus 7 by 3. Right? So here we have this. They have given us arithmetic mean of x as 1, mean deviation of x as 0.3. They're asking us coefficient of mean deviation of y. Coefficient of mean deviation of y is mean deviation of y by arithmetic mean of y into 100. For which we want mean deviation of y and arithmetic mean of y. I know arithmetic mean of x. I know this relationship. Can I calculate arithmetic mean of y? Yes. Y bar is equal to a plus b into x bar. A is 7 by 3. B is minus 2 by 3. X bar is 1. So minus 2 by 3 into 1 is minus 2 by 3. 7 by 3 minus 2 by 3 is 5 by 3. Or 1.667. This is arithmetic mean of y. Mean deviation of y. If y is equal to a plus b into x, mean deviation of y will be equal to
Modulus of b into
modulus of b into mean deviation of x. Modulus of b. What is modulus of b here?
2 by
plus
2.
2 by
2 by 3. Correct. Minus 2 by 3 modulus. Ignore the negative. 2 by 3 into mean deviation of x is 0.3. So 2 by 3 into 0.3 will give us the mean deviation of y. What is the mean deviation of y? I think 0.2.
0.2.
Yes, we get 0.2. Now we have both. Just apply this formula. Mean deviation of y divided by y bar into 100. We get 12% as the coefficient of mean deviation. Everyone understood?
Yes, sir.
Write that, then we'll move on to the next question.
Sir, could you please repeat that first step, sir?
Which one?
After expressing it as y in terms of y.
Okay, you understood y bar and okay, this one you're telling.
After that thing of expressing it as y, sir.
After expressing it as y, now why did we express it as y? To get the relationship between x and y. Y is equal to a plus b into x. They're asking us coefficient of mean deviation of y, for which I want y bar and mean deviation of y. So I know x bar. I know relationship between x and y. Can I calculate y bar? Yes, sir. If y is equal to a plus b into x, y bar is a plus b into x bar. So 7 by 3 minus 2 by 3 into x bar is 1. 7 by 3 minus 2 by 3 is 5 by 3. That is y bar. Understood?
Yes, sir. Yes, sir. Understood.
Similarly, mean deviation of y is modulus of b into mean deviation of x. This is the property that we have discussed. So
Yes, sir.
b is minus 2 by 3. Modulus of b is 2 by 3. Into mean deviation of x, they have given 0.3. So with this, if you simplify, you get 0.2.
Yes, sir. Thank you. Sir.
Coefficient is 0.2 by 1.667 into 100.
Yes, sir. Thank you, sir.
Done? Anyone still writing this? Yes. Okay. Next question. Question number 68. If arithmetic mean and harmonic mean for two numbers are 5 and 3.2 respectively, geometric mean?
C4.
4.
4. Yes. We know the property, right? Geometric mean is root of a into h. So root of 5 into 3.2. 5 into 3.2 is 16. Correct? Root of 16 is 4. So geometric mean is 4. That is question number 68. Next one. What is the coefficient of range for the following distribution?
Sir, 72.46, sir.
Very good. Coefficient of range, we need to identify largest value and smallest value. In case of continuous distribution, the class boundaries. Correct? First class intervals, lower class boundary. This is 10 to 19. This is 20. So 1, 0.5. 10 minus 0.5. 9.5 is the lower class boundary. So 9.5 is the smallest value. Upper last class intervals, upper class boundary. 50 to 59 plus 0.5. So 59.5 is the largest value. Then we know coefficient of range, L minus S by L plus S into 100. 59.5 minus 9.5 is 50. 59.5 plus 9.5 is 69, I think. Into 100. We get 72.46. If anyone is not understanding, can always ask. Since these are the concepts which we have already discussed, just now we discussed, I'm going through this a little quicker because these are simple questions. Done? Completed?
Yes, sir.
Yes, sir.
Yes. Next question. Question number 70. If there are two groups with 75 and 65 as harmonic means and containing 15 and 13 observations, combined harmonic mean. Same
70.
problem we had solved in the class.
70, sir.
Yes. So the formula is N1 plus N2 divided by N1 by H1 plus N2 by H2. N1 and N2 are 15 and 13. 15 plus 13 is 28 divided by 15 by 75 plus 13 by 65. 15 by 75 is 0.2. 13 by 65 is also 0.2. 28 by 0.4, which is 70. Done? Next question, 71. If x and y are two random variables, then variance of x plus y when x is independent of y. Okay, this is not related to this chapter. We'll come to this a little later. Right? Once we discuss probability, we'll come to this. Geometric mean is a better measure than others when
Ratios and percentages are
yes, when ratios and percentages are given. Correct? We have already discussed this. It's the best measure when ratios and percentages are given. Sum of squares of deviation from mean of 10 observation is 250. Mean of the data is 10. Find the coefficient of variation. Everyone try. These are simple questions. Okay, if you can solve these questions, you'll get the confidence. Similar questions will be asked in the exam. What we have to do is read the question once more. You get what is given in the question. If you get what is given in the question, you can easily compute the
50%, sir.
yes. Now, for calculating coefficient of variation, we know we want standard deviation by arithmetic mean into 100, of which arithmetic mean they have already given mean is 10. What is this? Sum of squares of the deviation from mean. Summation x minus
X
x bar the
minus
whole
X bar.
square. This is 250 they have given. N is 10. And I know standard deviation is root of summation x minus x bar the whole square by n. So this is 250 divided by 10. 250 by 10 is 25. Square root of 25 is 5. So standard deviation is 5. Arithmetic mean is 10. Standard deviation by arithmetic mean 5 divided by 10 into 100, 50%. Five divided by 10 into 100, 50%. Done? We'll move on to the next question. Equation of a line is 5x plus 2y equals 17. Mean deviation of y about mean is 5. Calculate mean deviation of x about mean.
True, sir.
2 is correct. 2 is the right answer. Am I audible?
Yes,
Yes, sir.
Right. Okay. Okay. So we'll discuss that question. 74th question. Okay. Am I audible now?
yes, sir.
Yes. Okay. There was some disturbance, technical issues. Okay, no problem. We'll continue. So we had to discuss 74th question, right? Question number 74. It's given us, they have given us 5x plus 2y is equal to 17. So I can express it as, what I have to do, I have to express it in the form of
Y is equal to X.
so 2y is equal to minus 5x plus 17, or y is equal to minus 5x plus 17 by 2, or y is equal to minus 5 by 2x plus 17 by 2. Now they have given us mean deviation of y. MD of y is equal to 5. Now if y is equal to a plus b into x, I know mean deviation of y is equal to modulus of b into mean deviation of x. Mean deviation of y is given as 5. Modulus of b is 5 by 2 into mean deviation of x. So mean deviation of x is send 5 by 2 to the other side into 2 by 5. This gets cancelled. Mean deviation of x is 2. Understood? That was question number 74. Now we will move on to the next question. If variance of x is 5, find the variance of 2 minus 3x.
Minus 13.
No, variance cannot be negative, because variance is square of standard deviation. Standard deviation also cannot be negative. We have discussed that, right?
Sir, 45.
45. Correct. Now, variance is 5. That is variance of x is 5. If variance of x is 5, can I say standard deviation is root of 5? Now, that property, what they have given us, variance of 2 minus 3x. So that is y is equal to 2 minus 3x. Now, this property of change of scale and change of origin holds good only for standard deviation, not variance. So I cannot directly apply the variance. I have to apply standard deviation only first, right? So standard deviation of y is modulus of b into standard deviation of x. Modulus of b is minus 3. Modulus of minus 3 is 3 into standard deviation of x is root 5. So can I say standard deviation of y is 3 into root 5? But I want variance. Variance of y is square of 3 into root 5. 3 square is 9. Root 5 square is 5. 9 5s are 45. Understood? Done? Completed? That was question number 75. We'll move to the next question. Let the mean of the variable x be 50. Then the mean of u is equal to 10 plus 5x will be. Simple.
$260, sir.
260. Correct. Now they have given us u is equal to 10 plus 5x. They're asking us arithmetic mean u bar. So can I say u bar is equal to 10 plus 5 into x bar? Yes. They have given us x bar as 50. 10 plus 5 into x bar is 50. 50 into 5, 250. 250 plus 10, 260. 260. That is question number 76. Simple. Next question. Sum of squares of the values is 3390. N is 30. Standard deviation is 7. Find out mean.
Sir, 113.
No.
8, sir.
8. Yes, 8 is the correct answer. Now, sum of squares of the values. Sum of squares of the values is summation x square. Summation x square is 3390. N is 30. Standard deviation is 7. Right? We know the formula for standard deviation. Square root of summation x square by n minus summation x by n the whole square or x bar the whole square. Now, this is 7 is equal to summation x square is 3390 divided by 30 minus x bar the whole square. 3390 divided by 30 is
113.
113. Divide minus x bar the whole square. Now we cannot further solve it unless we square on both sides. So square on both sides. 7 square is 49 is equal to 113 minus x bar the whole square. Send this the other side. We get x bar the whole square is equal to, send this side, 113 minus 49. X bar the whole square is 64. Therefore, x bar is 8. Completed?
Yes, sir.
Right. Next question. Question number 78. Which of the following measures of central tendency cannot be calculated by graphical method?
Mean.
Mean.
Mode, histogram, median and quartiles, we can get it through ogives. So it is mean, which cannot be calculated through graphical method. Right, that's all. So totally 18, 61 to 78, 18 minus 1, 71st question was not related to this chapter. So totally 17 questions out of 40 from the first two. Right, so this was the first paper. We'll look into the next one. This was April 21, April 2021. The best method to collect data in case of natural calamity.
Direct interview.
Indirect interview.
Personal interview.
Direct.
Personal,
interview.
personal, direct. In case of accidents, it is indirect. In case of natural calamities, it is direct, personal interview. Which of the following statements is true?
Mean is the best measure of central
Usually
tendency.
Mean is the best measure of central tendency. Simple, right? Next one. Mean salary for a group of 40 female workers is 5,000 per month. That for a group of 60 male workers is 6,000 per month. What is combined mean?
So 5,600.
5,600.
Yes. This is N1, X1 bar, N2, X2 bar. We have to just apply the formula. N1 into X1 bar plus N2 into X2 bar divided by N1 plus N2. 40 into 5,000 is 2 lakh. 60 into 6,000 is 3.6 lakh divided by 100. That is 5.6 lakh by 100, 5,600. Clear? Yes. Next one. Standard deviation of 10, 16, 10, 16, 10, 10, 16, 16.
So 6.
No.
Three, sir.
Yes, it is 3. Okay, there are two ways of solving. One is applying the formula. Second, see, what is standard deviation? Standard deviation is deviation from arithmetic mean. Correct? So, if you look into this, what would be the arithmetic mean? 13. Arithmetic mean is 13. All values are consistently deviating from the arithmetic mean by 3. It is plus 3 or minus 3. So, it should be 3. Alternatively, if you apply the formula 10, 16, 10, 16, 10, 10 and 16, 16, you have to find out x square, summation x or x bar, we already know 13. So x square value 100, 256, 100, 256, 100, 100, 256, 256. So it is 256 into 4 plus 100 into 4. Summation x square we get 1424. Summation x square we get 1424. Then we have to just apply the formula. Root of summation x square by n minus x bar the whole square. Summation x square is 1424 by n is 8 minus x bar the whole square. 13 square is 169. 1424 divided by 8, we get 178.
178
Minus
169.
178 minus
Root
169
of
is
9.
9, which is 3.
Sir, even like standard deviation is equal to half of range. Using that formula also.
Yes, you can do that. Half of range, yes. 10 minus 6 or 16 minus 10, which is 6 divided by 2. Next question. When mean is 3.57, mode is 2.13, value of median. What's the answer? Who's that?
Sir, 3.09.
3.09, correct. Mean is 3.0. Median is 3.09. So how do we calculate? Using the empirical relation.
Empirical relationship.
Yes. We all know mode is equal to 3 median minus 2 mean. They have given us mode as 2.13 is equal to 3 median minus 2 times 3.57. So 3 median is equal to 2.13 plus 2 times 3.57 is 7.14. This gives us 9.27. Therefore, median is 9.27 divided by 3.09. Done? Next question. The variance of the data 3, 4, 5, 8. Yes. They have given us the values of x 3, 4, 5, 8. Total of this is 20. Therefore, x bar is 5. X square values are 9, 16, 25, 64, 114. I think the total, yeah. Therefore, variance is summation x square by n minus x bar the whole square. 114 by 4 minus 5 square is 25. That is 28.5 minus 25. That is 3.5. Everyone understanding? Done? Next question. Question number 67. If profits of a company remain the same for the last 10 months, standard deviation of the profits for these 10 months.
0.
If all the observations
Zero.
are constant,
Zero.
standard deviation is 0. Yes. Points of intersection is of less than ogive and greater than ogive curve gives us
Median.
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 Very good. Following frequency distribution is classified as
Discrete distribution.
Discrete frequency
discrete
distribution.
frequency distribution. Very good. Discrete distribution. Median of the data.
Eight.
8, sir.
Yes. Sorry, not 8. Arrange it in descending order, ascending order. Sorry, 2, 4. Yes, 9.5 is correct.
9.5, so
11, 13, and 15.
2, 4, 6, 8, 11, 13, 15, 18. Correct. So middle, there are two middle values here. 8 and 11. So 8 plus 11 by 2, 9.5. Done? Completed?
Yes, sir.
Next one. AM and HM for two numbers are 5 and 3.2. Then geometric mean. We have same question. Previous one. 4.
4.
Right? Same question. Same question. So we need not solve again. Value of the first quartile for the observation. Calculate Q1.
12.
No.
12.75.
12.75.
12.7.
Yes. So first we have to arrange it in ascending order. 10, 12, 15, 16, 18, 20, and 23, 28, I think. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yes. So we want Q1, that is n plus 1 into 1 by 4. Right? Q1 is 1 by 4. Now 8, n is 8. 8 plus 1 into 1 by 4. 9 by 4 is
2.2.
2.25.
correct. That is second value, which is 12
Yes.
plus 0.25 into third minus second.
15.
15 minus 12.
Yes, 15 minus 12, which is 3. 3 into 0.25 is 0.75,
0.75.
which is 12.75. Done?
Yes.
Yes. If we are done with that question, we'll move on to the next question. Question number 73. What is the coefficient of range from the following data? Same question. Again, repeated 72.46. Okay, same, which we have already solved in the previous paper. Which measure of dispersion is based on all the observations?
Mean deviation.
It's a mean deviation and standard deviation, but not C. Option D.
Option D. Mean deviation is based on all observation. It says x minus a by n modulus. So based on all observation. Standard deviation is obviously based on all observations, but quartile deviation not. Therefore, A and B, but not C. Option D is the correct answer. Next question. This is interesting. Interquartile range is dash of quartile deviation.
Equal.
No.
Sir, double.
Yes, double. Now we have discussed quartile deviation is what? Semi-interquartile range. Semi-interquartile range. Why? What is quartile range? Interquartile range Q3 minus Q1.
Minus
Range. Correct. Whereas quartile deviation is Q3 minus Q1 by 2. So quartile deviation is half of that. Or interquartile range is double of quartile deviation. Interquartile range is double the quartile deviation. Understood? Next question is again repetition. Sum of squares of the deviation from mean of 10 observation is 250. Mean of the data is 10. Coefficient of variation. We get standard deviation of 5. 5 by 10 into 100, 50%. We have already solved this. Next question. Mean, same repetition. Mean of the variable of x is 50. Mean of u is equal to 10 plus 5x. Again, we have solved this. 260. 5 into 50, 250 plus 10, 260. Next one. Standard deviation of a variable x is known to be 10. Standard deviation of 50 plus 5x.
100.
500.
50.
50. Yes. So they have given us standard deviation of x as 10. They have given us y is equal to 50 plus 5x. We know standard deviation of y is modulus of b into standard deviation of x. Modulus of b is 5 into standard deviation of x is 10. 5 into 10, 50. Simple. This is question number 78. Next one, question number 79. The mean and standard deviation of a series is a plus b. If we add 2 to each observation of the series, then the sum of mean and standard deviation is
A plus B plus 2.
A.
very good. It is A plus B plus 2. Now, mean and standard deviation is A plus B. If 2 is added, this is change of origin.
Yes, sir.
Mean will get affected by change of origin. So, mean increases by 2. Correct? But standard deviation doesn't get affected by change of origin. It remains unchanged. So, the sum of mean and standard deviation would be A plus B plus 2. Understood, everyone?
Yes, sir.
Last question. Which of the following is affected by shifting of scale?
All of the above.
All the
All measures of dispersion are affected by change of scale, right? So all of the above. Yes, that's all. So we had 20 questions here, 61 to 80. 20 questions from this chapter, 50%. Right? So we'll move on to the next chapter, the next paper rather. Before that, can we take a quick break?
Yes,
Yes, take a break. We'll come back at 9:10. Then we'll look into the next questions, next set of questions.
Excuse me, sir.
Yes.
Sir, our college starts around 9:30, sir. So may I leave the class around
Sure,
9:50?
those who have college, you can leave. Anyhow, we can cover it up later. No problem.
Sure, sir. Thank you so much, sir.
Okay. Friends, are we back?
Yes, sir.
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 Yes, right. So we'll continue with our discussion. We'll look into some other questions from the chapter. We are done with that paper. Then we'll move on to the next paper, October 21 paper. Yes, statistics is concerned with
Both qualitative and quantitative.
Both,
yeah.
sir.
So even though it is only deals with only quantitative, it is concerned with both A and B. Right? Primary data are collected by
All of them.
all the three methods: interview, observation, and questionnaire. Okay. The following data relate to incomes of 86 people. What is the percentage of persons earning more than rupees 1,500?
50%. 50.
Yes.
50%.
More than 1,500, 36 plus 7, 43 people. Out of 86, 43 divided by 86 into 100, 50%. Next question. The following data relate to marks of group of students. How many students got marks more than 30?
70.
Options.
35.
Yes, 35. This is below 10, below 20, below 30. This is less than cumulative frequency. What they have given us. So below 30, it is 65. Total, there are 100 students. That means above 30, it would be 100 minus 65. Correct. So 35 students. The curve obtained by joining the points where x coordinates are the upper limit of the class interval and y coordinates are corresponding cumulative frequencies.
OJ.
Oh, guys.
Yes, option A. Oh, guys, because cumulative frequency we are presenting. If x and y are related by x minus y minus 10 equals 0 and mode of x is known to be 23, what is the mode of y?
So 23.
Yes. Very good. Now they have given us x minus y minus 10 equals 0. I have to express it in the form of y is equal to a plus b into x. So I'll send y the other side. I get y is equal to x minus 10. Now mode of y is equal to mode of x minus 10. What is mode of x?
23.
23. So 23 minus 10, 13. Mode of y is 13, not 23, 13. Mode of y is 13. Clear? Next question is a repetition, which we have already solved. The two groups 75 and 65 are harmonic means containing 15 and 13 observations, combined harmonic mean. We got 70. Yes, we have already solved this. Quartile deviation of x is 6 and 3x plus 6y is 20. What is the quartile deviation of y?
Three.
Yes. They have given us 3x plus 6y is 20. I'll express it in the form of y is equal to a plus b into x. So 6y is minus 3x plus 20, or y is minus 3x plus 20 divided by 6, which is minus 3 by 6 or minus 1 by 2x plus 20 by 6. Now, we know that quartile deviation of y is modulus of b into quartile deviation of x. Quartile deviation of y, modulus of b is 1 by 2.
1 by 2.
Into quartile deviation of x is 6. Therefore, we get 3. Okay. This was 68. Question number. Now, question number 69. Which one is an absolute measure of dispersion?
Standard deviation.
All the three.
All.
Range, mean deviation, standard deviation. All the three are absolute measure. Correct? Relative measures are coefficients. So all the three are absolute measures. Next one, median of the following.
30.
37. Correct. So we have to just arrange it in ascending order. We get 26, 27, 30, 37, then 42, 44, 51. So the middlemost value is 37. Median is 37. Clear? Next one. Mean of the following.
Very
good. Yes. We get, if we add up, we get summation x as 410. N is 10. There are 10 numbers here. So 410 divided by 10, 41. If arithmetic mean of any distribution be 25 and one term is 18, then the deviation of 18 from arithmetic mean is... Read the question carefully.
Sir, 7.
-7.
Minus 7. Minus 7. See, deviation of 18 from arithmetic mean. This is x minus x bar they are asking us. X is 18. X bar is 25. 18 minus 25 is minus 7.
Sir, shouldn't we take it as modulus, sir?
Why? If they are given us absolute, then only, no?
Okay, sir.
Absolute deviation means modulus. Just deviation is as it is.
Okay, sir.
This is 72. Next one, 73. Algebraic sum of deviations of frequency distribution from its mean is always
0.
0.
0. That property that we have discussed. Pooled mean is also called as
Geometric mean?
Geometric mean.
grouped. Pooled means combined. Grouped. Right? Grouped mean. Pooled, grouped mean, combined mean. If x and y are related by y is equal to 2x plus 5 and standard deviation and the arithmetic mean of x are known to be 5 and 10 respectively, coefficient of variation of y. That is missing. Coefficient of variation of y.
25.
Yes?
25.
No?
Sir, 40.
40. Yes, 40 is the correct answer. Now, they have given us y is equal to 2x plus 5. They have given us standard deviation of x as 5, arithmetic mean of x as 10. They are asking coefficient of variation of y. So, coefficient of variation of y, I want standard deviation of y and arithmetic mean of y. How do I calculate standard deviation of arithmetic mean of y? Y bar is equal to 2 into x bar plus 5. That is 2 into 10 plus 5, 25. Standard deviation of y is modulus of b into standard deviation of x. Modulus of b, 2 into standard deviation of x is 5. 10. 2 5s are 10. So, coefficient of variation is standard deviation by arithmetic mean into 100, which is 40%. Okay, this
If
is...
we find coefficient of variation of x and then find coefficient of y, then
that property doesn't hold good, no? Coefficient of variation, change of origin, change of scale property doesn't hold good there for what do you say, relative measures of dispersion. It is only for absolute measure. Right. So this was question number 75. Now move on to the next question. Following are the, okay, this is probability, that's all. So these are the only questions that we have. 75, 15 questions from this. This was October 21. Now, next one, November 2021. Again, repetition. Statistics is concerned with
Both A and B.
both A and B. Primary data are collected by
All of this.
All
the three.
These.
Yeah. I think it's a repetition completely. Yes. Yeah, it's a repetition. Okay. Fine. We'll look into the next set only. Salaries of employees working in ABC Limited is as follows. Find the number of employees with salary more than 50,000.
35.
Sir, 58.
58. Correct. Salary more than 50,000, below 50,000, 65 people. Totally, there are 123 people. This is cumulative frequency again. 123 minus 65, 58. Right? 123 minus 55, 65, 58. Which of the following is not a criteria for ideal measure of central tendency?
Sir, first one, it should be ambiguously defined.
Yes. It should be unambiguously defined, right? There should not be ambiguity. So it should be ambiguously defined is not a criteria. Next one. Which of the following is not an example of continuous variable?
Number of road accidents.
Number of road accidents. It is discrete. Temperature is continuous, profit is continuous, height is continuous. At ABC Limited, average age of employees is 36. Average age of male employees is 38 and that of female employees is 32. Find the ratio of female to male in the company.
Sir, 2:1.
1:2.
Sir, 1:2.
Very good. 1:2. That's why we have to read the question carefully. It is ratio of female to male, not male to female. Right? Average age of the employees is 36. So I can consider it as combined. Average age of male employees is 38. If I say there are X male employees, female employees is 32. 32 female employees, 32 age, 1 minus X female employees, or you can take Y also, right? If I take this, it will be easy for me to calculate. 36 is equal to 38X plus 32 minus 32X, 38 minus 32 is 6. 36 is equal to 6X plus 32. 6X is equal to, if I send 32 the other side, 36 minus 32, 4. Or X is 2/3. So X represents male. So male are in the ratio of 2:1. For every total 3, there are 2 males. Correct? So 2:1, male to female. I want female to male, 1:2. Understood?
Sir, do you
Didn't get that, Varshini. Can you repeat? You're not audible. I think there is some issue. There's some issue with your connection. I think you can chat if you have any doubts. Next question. Meanwhile, the mean height of girls in the class is 162 centimeter, while for boys is 182 centimeters. Ratio of number of girls to boys is 1:2. Mean height of whole class.
Sir, 170 centimeter.
170 centimeter, no.
None of
Correct. What's the answer?
175.33.
Yes, the answer is 175.33. Mean height of girls is 162, boys is 182. Ratio of girls to boys is 1:2. So I can consider 162 into 1 plus 182 into 2 divided by 1 plus 2. Combined arithmetic mean. Correct. So 162 plus 182 into 2 is 364 divided by 3. So if you add up and further simplify this, we get 526 by 3, which is 175.33. So none of this. Done. Next question. 66. In the equation 4 plus 2y is equal to 3. Quartile deviation for y is 3. Quartile deviation for x.
1.5.
Yes, 1.5. Now we have 4x plus 2y. I'll express it in the form of y is equal to a plus b into x. So 2y is equal to minus 4x plus 3, or y is minus 4x plus 3 by 2, or y is minus 2x plus 3 by 2. Now we know quartile deviation of y is equal to modulus of b into quartile deviation of x. Quartile deviation of y is 3. Modulus of b is 2 into quartile deviation of x. Therefore, quartile deviation of x is 3 by 2, which is 1.5. Quartile deviation of x is 1.5. Next one. Standard deviation is independent of change of
Scale. Origin.
origin. Yes, independent of change of origin. Next one. Find D6 for the following observations.
$13.8.
No.
Sir, 12.4.
Yes. 12.4 is the correct answer. First, we have to arrange it in ascending order. Right? Ascending order, we have 4, 5, 6, 7, 9, 10, 14, 15, 18, and 20. Then D6 will be n plus 1 into 6 by 10. Correct? Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 plus 1 into 6 by 10. That is 11 into 6 by 10, 66 by 10, 6.6th value. That is 6th value plus 0.6 into 7th minus 6th value. What is 6th value?
10.
10 plus 0.6 into 7 is 14 minus 10. 14 minus 10 is 4. 4 into 0.6 is 2.4. That is 12.4. Clear? That is question number 68. Next question. If all the observations are decreased by 4, find the relation between new standard deviation and old standard deviation.
Remains unchanged.
Remains unchanged. Decreased by 4 is change of origin, doesn't get affected. So remains unchanged. Standard deviation of first n natural number is 2. What is the value of n?
Seven.
Yes. How did we get 7?
Sir, root of n square minus 1 by 12.
Right. N square minus 1 by 12. So n square minus 1 by 12 is 4. N square minus 1 is 48. N square is 49. Therefore, n is 7. What is n square minus 1 by 12? This is the standard deviation of first n natural numbers. So if formula, if standard deviation of first n natural numbers is 2, you have to just simplify this, you get 7. Alternatively, if you don't remember this formula, if you can go with trial and error method also. You have to just calculate first n natural numbers. You have the options, right? 7, 1, 2, 3, 4, 5, 6, 7. Calculate standard deviation. If you get 2, that is the answer. If you don't get, go to the next option. That can also be done. Root of n square minus 1 by 12. Standard deviation of first n natural numbers. Next, question 71. Find the variance of 3x plus 2 if standard deviation of x is 4.
$144.
Correct. So we have y is equal to 3x plus 2 and standard deviation of x is 4. I can calculate standard deviation of y using this modulus of b into standard deviation of x. That is 3 into 4. 3 4s are 12. But I want variance. 12 square 144. That was 71. Next question 72. If variance of x is 148.6, mean is 40, coefficient of variation.
30.48.
Very good. 30.48. They have given us variance of x 148.6. What is standard deviation?
12.190.
12.190. And mean is 40. So coefficient of variation is 12.190 divided by 40 into 100. 30.48. Next question, question number 73. Average of 10 observations is 14.4. Average of first 4 observation is 16.5. Average of remaining 6 observations.
13, sir.
Yes, correct. 13. Average of 10 observations is 14.4. So I can consider this as the combined arithmetic mean. Right? 14.4 is combined arithmetic mean. First 4 observation is 16.5. So 4 into 16.5 plus average of remaining 6 observations, we do not know. 6 into x I will consider. 4 plus 6 is 10. So cross multiply 14.4 into 10 is 144. 16.5 into 4 is 66 plus 6x. 6x is equal to 144 minus 66, we get 78. So x is 78 by 6, which is 13. Therefore, average of the second set is 13, 1, 3. Understood? Yes. Okay. So that was question number 73. Next question. If the rates of return from 3 different shares are 100%, 200%, and 400% respectively, average rate of return.
200%.
Very good. So when they are asking us average of rate of return, what is the measure that I have to use?
Geometric.
Geometric. 100%, 200%, 400%. You can convert it into decimals. 100% can be written as 1.00. 200% can be written as 2.00. 400% can be written as 4.00. You can still consider 100, 200, 400. Calculations become a little larger. See, if you have 80%, I can write it as 0.8, right? Similarly, 100% is 1, 200% is 2, 400% is 4. Cube root of 1 into 2 into 4. Product. 4 2s are 8. 8 into 1, 8. Cube root of 8 is 2, which is nothing but 200%. Or if you want to consider cube root of 100 into 200 into 400, you still get 80 lakh. Cube root of 80 lakh is nothing but 200. 200 into 200 into 200, we get 80 lakh. So 200% is the answer. Is that clear?
Yes.
That is question number 74. Next question. That's all. So these are the questions from this chapter of, this is November 21 MTP. Next one is March 22 MTP. March 22, median of a distribution can be obtained from.
Okay.
Correct. Cost of sugar in a month under the head raw material, labor, direct production and others were 12, 20, 35 and 23 units respectively. What is the difference between central angles for the largest and the smallest component of the sugar?
72 degree.
No, not 72.
92.
92 is correct. Yes. So here, this is pie chart concept, right? We have to calculate the degrees. We have 12, 20, 35 and 23. Since we have not calculated the degrees, I'll calculate for all. But technically, we need not calculate for all. We need to just calculate for highest and the lowest. 12. What is the total?
90.
90. So 12 divided by 90 into 360, we get 48 degrees. 20 by 90 into 360,
80.
35 by 90 into 360, 140.
140.
And 23 by 90 into 360, 92.
92.
So here the largest degree, 140, smallest is 48, 140 minus 48, 92. Difference they're asking us. Understood, everyone? Yes, this is 62. In a study relating to laborers of a jute mill, similar question we had solved in the class in West Bengal. The following information was collected. 20% of total employees were females and 40% of them were married. 30 female workers were not members of the trade union. Compared to this, out of 600 male workers, 500 were members of the trade union. 50% of the male workers were married. Unmarried non-member male employees were 60, which formed 10% of the total male employees. Unmarried non-members of the employees were 80. On the basis of this information, the ratio of married male non-members to married female non-members. 1 mark question.
Sir, 1:3.
Sir, 4:1.
4:1 is correct. Okay, so they are telling what have they given us? 20% of the total employees were female, right? Then they have given us out of 600 male employees. So if 20% of total are female, 80% is male. So if I have 600 male employees, which is 80% of it, so 600 divided by 80%, I get 750, which is total number of employees. Correct? 750 is total. In that, female will be 150. Everyone understood this concept? Right? 40% of them were married. So out of 150, 40% were married. So 150 into 40%? 60. So unmarried is 90. Right? Then 30 female workers were not members of the trade union. We do not have the breakup of married and unmarried. So I'll come to that particular data little later. Compared to this, out of 600 male workers, 500 were members of the trade union. 50% of the male workers were married. So how many people were married male?
$300.
300, correct. 300 married, 300 unmarried, correct. Unmarried non-member male workers were 60. So out of unmarried, non-members were 60. That means how many members who were unmarried?
40.
240.
240. Right? Then they had given us out of 600 male workers, 500 were members. So out of that 240 are unmarried out of 500 members. How many married members then? See, there are total 500 members.
260.
Out of that 240 are married. So 260, balance 260 are married members. And then the number of people who are married but non-members?
40.
Out of 300, 260 are members. So 40 are non-members. Everyone understood till here?
Yes.
Next one. They are telling us unmarried non-members of the employees were 80. So total unmarried non-members were 80. Out of total unmarried non-members, 60 are male. Unmarried non-members, 60 are male. So balance 20 will be female.
Yes, sir.
So non-members, unmarried female are 20. So who unmarried members are 70. Out of 90, if 20 are non-members, 70 members. Then come to this, we had 40% of them were married. Then 30 female workers were not members of the trade union. Out of 30 female workers who are not members, 20 are unmarried. Then how many are married?
10.
10. So out of married, can I say 10 are non-members? If 10 are non-members, how many are members?
50.
50 are members. So we have all the information. They're asking us ratio of married male non-members. Married male non-members are 40. To married female non-members. Married female non-members 10. So 40:10, which is 4:1. Done? Anyone still writing this? Okay, right then. So we'll move on to the next question. Question number 64. For non-overlapping classes 0 to 19, 20 to 39, 40 to 59, class mark of 0 to 19.
9.5.
9.5. Class mark is midpoint. 19 plus 0 by 2, 9.5. For open-end classification, which of the following is the best measure of central tendency?
Median.
Median, sir.
Correct. Quartiles of the variables are 45, 52, and 65 respectively. What is the quartile deviation?
10.
Q3 minus Q1 by 2. 65 minus 45 is 20 by 2, 10. Correct. If x and y are related by y is equal to 2x plus 5 and standard deviation and arithmetic mean of x repeated are known to be 5 and 10 respectively, coefficient of variation of y we have already calculated 40%.
40.
For a moderatively skewed distribution, median is twice the mean, then mode is dash times the median.
3 times.
3 by
median.
2.
No. Both are wrong.
Sir, 2 by 3.
No. See, they have given us median is 2 times mean, and we know that mode is equal to 3 median minus 2 mean. Right? 3 median minus 2 mean. So can I write this as 3 median minus, instead of 2 mean, can I write 1 median? 3 median minus 1 median is 2 median. So mode is 2 times median. Understood? This is question 68. Next question. If average marks for a group of 30 girls is 80, group of boys is 70, combined average is 76, how many boys are there in the group?
Sir.
20. Average marks of 30 girls is 80. So 30 into 80 plus average of boys is 70, but we do not know number of boys. So 70 into x divided by 30 plus x is 76. So further simplify, 30 into 80 is 2400 plus 70x is 76 into 30 plus x. 76 into 30 is 2280 plus 76x. Send this the other side, 2280 this side. 2400 minus 2280 is 120 is equal to 6x. 76 minus 70. Therefore, x is 20. Clear? Right. Next question. Question number 70. Median of the following observations. Very good. So if we arrange it in ascending order, we get 19, 36, 48, 56, 66, 72, 87, and 91. So we have 4, 4. So we have two mid values, 56 plus 66, average 61. If two variables A and B are related by C is equal to AB, then geometric mean of C. We just discussed this.
Geometric mean of A into geometric mean of B.
Geometric mean of A into geometric mean of B. Very good. If there are three observations, 15, 20, and 25, sum of deviations of the observation from their arithmetic mean?
0.
0. We need not calculate here. Property, directly 0. Mean weight of 15 students is 110 kgs. Mean weight of 5 of them is 100 kgs. And another 5 is 125 kgs. Mean weight of the remaining students.
$105.
Yes, it is 105. So it is combined arithmetic mean, but we have three values. That's all. Mean weight of 15 students is 110. So 110 is combined arithmetic mean. 5 students is 100. 5 into 100. Another 5 is 125. 5 into 125. Balance 5 we do not know. So 5 into x divided by 5 plus 5 plus 5, 15. 110 into 15 we get 1650 is equal to 5 into 100 is 500. 5 into 125 is 625 plus 5x. 500 plus 625 is 1125. If I send that the other side, 5x is equal to 1650 minus 1125. We get 525.
525.
Therefore, x is 525 by 5, 105. Therefore, the arithmetic mean of last set of 5 students, 105. We have to just use combined arithmetic mean concept. Understood? Yes. Okay. Next one. If arithmetic mean between two numbers is 64, geometric mean between them is 16, harmonic mean between them is
4, sir.
yes. We know that G square is equal to A into H. G is 16. 16 square is 256. A is 64 into H. Therefore, H is 256 divided by 64, which is 4. Simple. Last one. No, that's all. So this is March 22. Now the last paper, which is the recent one, November 2022. November 22. Yes. Distribution of profits of a company follows which shaped curve?
Bell-shaped curve.
Bell-shaped curve. Median of a distribution can be obtained from
Less than type.
Less than type of
less than type
Hodges.
of guide. Frequency density corresponding to a class interval is the ratio of
Class frequency to the class length. To the class.
yes. Option B, class frequency to the class length. This we have already done. Cost of sugar, difference between central angle, 92 degree with it we got. In a group of persons, average weight is 60 kgs. If average of males and females taken separately is 80 kgs and 50 kgs separate, respectively, find the ratio of number of males to that of females.
One is to 2.
1:2. Average weight is given to be 60. Average of males and females taken separately 80x plus 50 into x minus 1 minus x I can consider. So 60 is equal to 80x plus 50 minus 50x. If I send 50 the other side, 60 minus 50 is 10. 80x minus 50x is 30x. So can I say x is 1/3? What is x? X represents male. So 1 for every 2 females. Total 3 people, 1 for every 2 females, 1:2 is the ratio of male to female.
So my doubt was, why are we not dividing by number of male plus female?
Correct. If we do that, what happens? Number of male is x. Number of female is 1 minus x.
Okay.
That's why
Yes.
if we take x and y, even still we get the ratio. But if we take x and 1 minus x, we get it very easily.
Yes, sir.
Next question. A train covered first 5 kilometers of its journey at a speed of 30 kilometers per hour. Next 15 kilometers at a speed of 45 kilometers per hour. Average speed of the train.
Forty
40 kilometers.
40 kilometers, correct. So this is harmonic mean. And we have frequencies given, right? 30 kilometers, 5 kilometers, 30 kmph, 5 kilometers, 45 kmph, 15 kilometers. So total 5 plus 15, n1 plus n2 divided by 5 divided by 30 plus 15 divided by 45. So if we do this, 5 plus 15 is 20, 5 by 30, 1/6, 15 by 45 is 1/3. 20 divided by, further simplify, 1 plus 2, we get 3/6, 20 into 6/3, 3 ones are 3 twos are 22s are 40. 40 kilometers per hour. Next one. If 2x plus 3y plus 4 is equal to 0, variance of x is 6, then what is the variance of y?
Eight by 3.
Yes, correct. So they have given us variance of x as 6. So can I consider standard deviation of x is √6? And 2x plus 3y plus 4 is equal to 0. I want it in the form of y is equal to a plus b into x. So 3y is equal to minus 2x minus 4. Y is minus 2x minus 4/3, or y is minus 2/3x minus 4/3. So standard deviation of y will be equal to modulus of b into standard deviation of x. Modulus of b is 2/3 into standard deviation of x is √3. I do not want standard deviation, I want variance. Variance of y is 2/3 square is 4/9. √6 square is 6. So 3 2s are 3 3s are 4 2s are 8 by 3. Done. Next question. If standard deviation of 1, 2, 3, 4 up to 10 is sigma, then the standard deviation of 11, 12, 13, 14 up to 20 is
10 into sigma.
10 into sigma.
Sigma.
What have we done here? We have added 10 to each of the observations.
10 plus sigma.
Right? 1 plus 10, 2 plus 10, 3 plus 10. That means it is change of origin. Doesn't get affected by change of origin. So it will remain sigma. Correct? It doesn't get affected by change of origin. So it shall remain sigma. Next one. What is the standard deviation of the following series? Because standard deviation is 9? No? Simple calculation. Okay, anyone's writing this? Completed? Okay, we'll move on to the next question then. Question number 70. If the difference between mean and mode is 69, difference between mean and median.
$23.
Very good. So they have given us mean minus mode is 69. Now in that empirical relationship, we know mode is equal to 3 times mean minus median. 3 times mean minus median, or
Mean minus mode equal to 3 into mean minus median.
okay, mean minus mode is equal to, correct, mean minus mode is equal to 3 times mean minus median, correct. That is what we have in that empirical relationship. So mean minus mode, we know 69 is equal to 3 times mean minus median. So they are asking us mean minus median. Mean minus median is what? 69 divided by 3. 23. 69 divided by 3, which is 23. Next one. If all the observations in a distribution are increased by 6, variance of the series will be
Unchanged.
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 Plus change of origin doesn't get affected. Which measure of dispersion is based on absolute deviation only?
Mean deviation.
Yes, mean deviation is summation modulus of x minus a. So absolute deviation only, mean deviation. Calculate the value of third quartile from the following data. We'll quickly finish this. Couple of more questions. We'll finish this off. What is the value of Q3 that we get? You have to arrange it in ascending order.
36.2.
36.25. How did we get 36.25? What is the ascending order that we get?
16,
Yes, 21.
21, 25, 27, 29, 32, 35,
Yes,
40, 51.
40 and 51. Correct. Now Q3 is n plus 1 into 3 by 4. What is n?
9.
9. 9 plus 1 is 10. 10 into 3 by 4 is 30 by 4. 30 by 4 is?
7.5.
Correct. Everyone got this? 7.5.
Yes, sir.
7th value plus 0.5 into 8 minus 7th value. What is 7th value? 1, 2, 3, 4, 5, 6, 7, 35. 35 plus 0.5 into 40 minus 35 is 5. 5 into 0.5 is?
2.5.
We get 37.5.
Yes, sir.
Yes. Options are wrong. Q3 is 37.5. Next one. The mean of 100 students was 45. Later on, it was discovered that the marks of 2 students were misread as 85 and 54 instead of 58 and 45. Find the correct mean.
Sir, C, 44.64.
Correct. N is 100, X bar is 45. So can I say wrong value of summation X is 4,500? 45 into 100. From that, I have to reduce wrong values of X. That is 85 and 54. Add correct values of X. What are the correct values of X? 58 and 45. So this gives me revised summation X, which is 4464. We get 4464. Therefore, arithmetic mean is 4464 by 100, 44.64. 44.64. Clear? Right. Next one. Arithmetic mean and coefficient of variation of the data set X are respectively 10 and 30. The variance of 30 minus 2X. Yes, it is 36. Arithmetic mean is 10. Coefficient of variation is 30. So I can calculate standard deviation from this. This is 30%. Standard deviation by 10 is equal to 0.3. Therefore, standard deviation is 3. This is of X. They are giving us Y is equal to 30 minus 2X and asking us to calculate variance of it. So standard deviation of Y is modulus of B into standard deviation of X. B is minus 2. Modulus of B is 2 into 3. So standard deviation of Y is 2 3s are 6. Therefore, variance of Y is 36. Understood? Yes. Next question. Approximate ratio of standard deviation, mean deviation, quartile deviation. Okay, I think this is better if we discuss the next chapter, theoretical distribution, and then come to this question. Right? Answer is 15:12:10. How we'll discuss once we discuss theoretical distribution chapter. Next one. Geometric mean of 3 numbers, 40, 50, and X is 10. What is the value of X?
Five, sir.
Sir, 0.5.
The 1/2.
1/2, 0.5. Yeah, 1/2. Simple. Geometric mean 3 values. So cube root of 40 into 50 into X is 10. To solve this, I'll take cube on both sides. 40 into 50 is 2000. So I'll get 2000 X. 10 cube is 1000. X is 1000 divided by 2000, which is 1/2. Simple. Difference between upper limit and lower limit of a class is called
Class size.
class size. That's it. So this was the MTP which was released for your exams, December exams, November 2022 MTP. So with this, we have solved 6 MTPs, last 6 MTPs, so almost 100 questions, right, from the first 2 chapters. So we have covered all possible scenarios, right, the questions that can be asked. So with that, we are done with 2 chapters, 17 to 18 marks in the exam. Okay, so it is worth the time that we have spent is worth. We have solved multiple questions. What you can do is today you can focus specifically on these 2 chapters extra, so that out of these 18 questions, you can easily score all 18 or at least 16 to 17 questions, right? So you can prepare in that manner, and other chapters, as whichever is comfortable to you, you can prepare. Tomorrow we can finish the other part of the statistics, and even we can finish logical reasoning tomorrow. Okay, so other chapters are simple. We can look into them and quickly finish. Yes. Okay. Any doubts in this, whatever we had till now? No? Right then. We'll continue in the next class tomorrow.